But what do you treat what? Treat somebody
Cancer.
What?
Cancer's like the main one.
But you don't want to use cancer. Using a
Specific area.
and then
Specific target.
that's like the toxicity. Chemotherapy is using a chemical to treat a disease. I mean,
What the heck, man?
so right here, antisepsis means what?
Shut up, man.
So antiseptics, antisepsis, reduction in number of microorganisms and viruses, particularly potential pathogens, but what's the key to this one?
Living tissue.
Living tissue. Okay? You do not disinfect yourself, we'll talk about that later. You use antisepsis or you can antiseptic. Okay? Why is this a particularly pathogen? Do you care if it's not a pathogen really on you, if you're going to worry about it? Not really. If you look at here, alcohol iodide, that's what I talked about disinfectant. Antiseptics, a lot of times, are disinfectants that have been diluted. So they're not as potent. So you can use them on people. Aseptic refers to environmental or procedure free of pathogenic organisms. They talk about pathogenic contaminants or organisms here, but this is medical. In the lab, we talk about aseptic technique, right? I refer to this as refers to environment or procedure free of contaminants. Doesn't matter if you're trying to run. If you're in a lab, you're trying to find out what somebody has, and you cross-contaminate your plate, and it's not a pathogen. That's okay? Would that be okay? So I don't like the way it looked up. And then back over here, it jumps to scientists, laboratory technicians, and healthcare workers routinely follow standardized aseptic techniques. That's what you should be doing in the lab. I don't know why they have the pathogen in there. What does side or sidal mean? Just in general, what's the suffix side or sidal mean? Homicide, suicide.
To kill.
Kill, right? So the thing that is sidal is to kill. Indicating destruction of a type of microbe. Bacterial sidal means it's going to kill bacteria. Virucidal, fungicidal, fungus. Just because something will kill one does not necessarily mean it'll kill another one, right? Germicide is sort of a catch-all term for what?
Killing germs.
Something that'll kill anything we consider anything yucky out there, right? De-germing is the removal of microbes by mechanical means. The classic example of de-germing is hand washing. Okay. Phenolics. This is going to be, talk about this at the end of this one. Alcohol, aldehyde, soaps. Destruction, de-germing. I'm sorry, hand washing, alcohol swabbing is what I wanted. When they swab, when you get a swab before you get a shot, what's on that little swab?
Alcohol.
What's on that swab after they're done swabbing you? Dirty, right? You ever looked at it? That's the de-germing part. Alcohol helps kill the remaining of the organisms. The swab itself, the alcohol actually is de-germing. It's mechanically removing a lot of those organisms. Disinfection is the destruction of most microorganisms and viruses of non-living tissue. Key to disinfection is non-living. Okay? The term is used primarily in relation to pathogens. Again, you're not a... Again, is that true? That's only true in what setting? A medical setting, right? If you're in any other type of lab out there, you want to disinfect your temp benches and everything else. Okay. Pasteurization, we'll talk about that in a minute. The different types of pasteurization, what it means. But in general, it's used heat to destroy pathogen and reduce the number of spoilage microbes in foods and beverages. And it depends on how you do it, depends on how hot it's going to get. Okay. Do you remember that thing on mesophiles? What's the maximum temperature range you think mesophiles can survive at?
80.
No, like it's the max is like what was it like 30? No,
Right.
no,
80, 30, get moving in.
50?
60, right?
Ah.
60, 61. All pathogens are going to be what? Mesophiles, right? So pasteurization, sometimes there are certain things you don't want to heat up to the point of boiling. And you don't have to do that.
Is that
Sanitation refers to public health standards, right? Washing tableware with scalding water in restaurants. Making sure the temperature when they wash the glasses is warm enough or hot enough. Okay. How about picking up your trash? Would that be sanitation? How about cleaning public restrooms and parks?
Yes.
All that would fall under sanitation, right? Stasis or static indicate inhibition but not complete construction of the microbe. If something is static, it's going to slow its growth down. We'll get to that more when we get to antibiotics, because you have bactericidal antibiotics and you have bacteriostatic antibiotics. The mode of action is a little bit different. One thing they just have come across now, not come across, they just sort of discovered, is that several bacteria, when they get faced with antibiotics, kind of go into a stasis. They kind of go into a suspended animation. They quit metabolizing as much and growing. And that's a new mechanism they discovered for microbial resistance for some of these. And you'll see why when we talk about antibiotics next. All right, and then down here, I already jumped into this, sterilization, destruction of all microorganisms and viruses on an object. And the ultimate form of sterilization is incineration. If you incinerate something, you turn it to carbon, right? All right, I'll make this quick on this so we can get you guys caught up. All right. When we talk about the action of antimicrobial agents, including the drugs when we get to them, there are certain things you can target, and they're pretty much going to be the same. A, there's not that much to a bacteria, right? There's only so much you can go after. Cell walls and membranes. Cell walls maintain the integrity and protect us from osmotic pressure. You damage the cell wall, it becomes vulnerable to osmotic pressure. Cytoplasmic membranes control what stays in and what goes out, right? I mean, what comes in, not goes out. That's the same thing. If you can damage the cytoplasmic membrane and make it leaky, that also is going to kill the microbe. Things will start getting in you don't want in, things will start leaving you don't want. When we talk about non-invasive viruses, I'll tell you about those a little bit more in a minute. Have greater tolerance to these conditions. All right. Secondly, you all know proteins. When it comes to protein, structure determines function. So if you change the 3D structure, what have you done to its function? You've changed it. We talked about that with heat, remember? As the heat starts to change, you start changing its 3D structure, you start changing its function. Chemicals, radiation, and heat can alter and destroy nucleic acids. We'll talk about that in a minute. How do you irradiate things to sterilize them? What does it do? What is ionizing versus non-ionizing radiation? Halts protein synthesis. Produces fatal mutations. You give a bacteria enough mutations, it's just going to die over time. How come cockroaches are going to outlive us when a nuclear war hits? Y'all ever heard that?
Reconstruct their,
Huh?
aren't they able to like reconstruct their mutations?
We give it that too a little bit.
Yeah, but they're more efficient at doing that.
Could be. There's also a way their chromosomes separate that helps them do it. There's probably a lot of reasons. People shouldn't hate cockroaches, man. They've been around a long time, and they're going to be around a lot longer than we probably are. So.
Well, don't they say they can live up to like 2 weeks after their heads cut off? Like,
Yeah, something like that. I don't know if that's a
True.
urban legend or not.
Right.
Somebody want to try that at home?
Extra credit?
You need a whole lot first. Just make sure. All right. Let's go through these. Selection of an antimicrobial agent. Ideal agent should be inexpensive. You don't want to have to go pay. You don't want to have to go to Whole Foods and pay $50 for a gallon of some medicine, right? Fast acting. That's contact time. Did we go over contact time again?
A little bit.
Right, then contact time is.
Isn't it the time it takes for the germs to multiply in your body? Like when you're telling us about the restaurant?
No, that is generation time.
Oh, incubation. Or was it?
Contact time is the amount of time an antimicrobial agent must be in contact with the organisms to kill 95%.
Oh, it's the opposite amount.
That's fast acting. Stable during storage. You don't want to have to keep it cold. You don't want to have to keep it away from light. You don't want to have to worry about it separating into different solutions inside of it. You want stability. Capable of controlling microbial growth while being harmless to humans, animals, and objects. Ideally, you just want it to kill the organism. Does anything fall into this perfectly?
Not perfectly. Maybe bleach?
What do you think, bleach?
Oh no, but it's harmful to our eyes and
You want
animals.
to drink some bleach? What does bleach do to your furniture and stuff?
Bleaches it.
Your clothes. Oh, I got a little bacteria on here. Let me pour some bleach on here.
Like peels off the pigmentation.
Bleaches out the pigmentation, right? So bleaching is going to work with a couple. Is bleach inexpensive?
Yeah.
It keeps going up for some reason. I don't know why, but it's still fast acting.
Yeah.
Yeah. Stable during storage?
Yeah.
Bleach is pretty stable. It starts to gas off a little after a while. This is the one right here where you have a problem with bleach, right? Now you can dilute it, but still, I don't have any pairs of pants. I'm doing research. I messed up because I couldn't get home and wash it, but there'd be little spots all over my shirts and my pants.
What about alcohol?
Alcohol. Good. How does that fit in there? Is it inexpensive?
Yes.
Yes.
Is it fast acting? Relatively. Not bad. Is it stable during storage?
Yeah.
Pretty much. As long as you don't keep it sealed tight, you don't have evaporation. That's one problem, it evaporates off fast. That kind of goes back to the fast acting too. And we're talking about sites and issues with using different types of chemicals. But it's pretty good here. It's capable of controlling microbial growth while being harmless to humans, animals, and objects.
Yeah, for the most
For the
part.
most part. Alcohol probably fits this one the best, but then there's some things alcohol won't kill. How about, well, we'll talk about that at the end. This goes back to site being treated too. Excuse me, guys. Ew, that was disgusting. Sorry about that. Harsh chemicals of extreme heat cannot be used on animals, humans, and fragile objects. That goes back to what we were talking about. You want to put bleach in your eye? No. You want to put bleach on a big, huge, gaping scrape? I've done it. I think bleach. I meant alcohol.
Oh.
Bleach either. You want to put alcohol? Y'all know what road rash is?
Yeah.
When you were a kid, anybody ever had a nice piece of road rash? You? You look like you shook your head. I did that one time. I thought it was a good idea to pour some alcohol. Not a good idea. Animals too. You want to be careful with animals. We'll talk about some of the antibiotics later on. They can be toxic if taken internally. Fragile objects, least of my worries. But also heat. If something is very warm, and you put alcohol in it, what's going to happen?
Night.
Not quite that hot. But that's another potential problem too. Boom. Of course, you'll sterilize it, but what's going to happen to the alcohol if it's really, really warm?
Will evaporate temperature.
It's going to evaporate out before it has a chance to do anything. So all these are yet taken into control. Method of microbial control based on the site of the medical procedure. Even your eye. Do you want to put alcohol in your eye? No. What's one that works pretty well, except for the discoloration factor? They use it in hospitals all the time.
Chlorine?
Now chlorine must be iodine.
Iodine.
Iodine works pretty well. It doesn't burn too bad. It's a good disinfectant. Feature on the antiseptic. Problem is it stains everything, right? Right.
And that can be placed in fragile areas like eye and everything?
Somewhat. I think you can get iodine in your eye. I think it'd be up to you. Anybody know that? Anybody ever had iodine? You can, right? Yeah, pretty sure.
Wow.
Yeah, it's actually kind of weird. It's probably overall, except for the fact that it turns everything red or gold or whatever color. Okay, resistant here. We're going to go through different resistance to chemicals. What's an envelope virus?
It has some
I
sort
know I
of,
went over these a little bit before for you guys.
do you have some sort of like covering around it?
I need to go home today.
You're done.
It pulls off, it buds off, and it takes part of the membrane with it, right? But cellular membranes are relatively fragile, especially when they're outside of an organism. These are going to be very susceptible to almost any of these. They'll break down that membrane really quick. The virus uses it to attach. Gram positives next, then non-envelope viruses, then fungi, and then the gram negative, and then the active stage of protozoans called the tropozoans. We get the parasites, especially protozoans, we're going to get to a lot of the different life cycles. This part of their life cycle is the free living part where it's swimming around. Okay, it's not encysted, not a sort of, not like an endospore. That would be the cyst of the protozoa. Then mycobacterium, then endospores, because that's the whole point, right? Is to do what?
Oh, to save them.
To survive harsh conditions, right? And then last one's going to be prions. Why are prions so resistant?
What are prions?
What are prions? We haven't done prions.
I
Did you
don't
guys go over you should go over prions in 1306 and gotta make it. Prions? No?
I had you.
Yeah, we went over prions. When we went over protein, that's why I know we went over prions, because I just covered it. What's a prion, guys?
A protein that causes like misfolded other proteins or causes damage to the cell.
Right, so proteins, we talked, proteins, prions are misfolded proteins. Okay?
Miss what?
Mad cow, misfolded proteins.
It's folded. Oh.
So if you normally have a bunch of alpha helices in this particular protein, you remember those? Prions will misfold and have beta sheets. But since structure determines function, is that protein going to have the same function? No. And the weird thing about these proteins, these prions, is when they bump into a normally folded protein, that same type of protein, it causes it to change shape and fold into a prion. And since the protein is no longer functional, it's not going to be able to do its job. Right? And then those two go on and do what?
Make more.
Bump into a couple more. And they bump into a couple more. And these proteins tend to be in the brain, at least the ones we're talking about right now. So they're pretty important in the neurons in the brain. So the more of these prions that get scattered around and start damaging the other ones, the more damage you get in the brain. The brain starts to look like a what? Does anybody know what it starts to look like? It's called, mad cow disease is called bovine spongiform encephalopathy. Because the brain starts to look like a sponge. So it's getting these little holes all inside of it. And it becomes non-functional. The problem with prions, we talked about proteins. If you heat up a protein all the way, what do? What's that term called? Denature it. That means it unfolds. And most proteins, once they're denatured, they stay what? Denatured. Egg whites. You remember the egg whites? See? And an egg white is albumin, right? If you cook an egg, that egg white turns what? Whiter and turns solid. If you let that egg sit there for days and days and days, they're going to turn back into egg white? No. Problem with prions is once they cool down, they refold right back up.
What?
So you cannot get rid of them by standard sterilization, normal sterilization. They don't know, because energetically, this is more energetically favorable condition for them to be in.
So how do they treat that?
Kill them?
That's the problem. They don't. There's no treatment for it right now.
So is that kind of, can that kind of go into like Alzheimer's, like just?
Yeah, because Alzheimer's are just built up of beta amyloid plaques in the neurons, and then you start having tau, these other proteins called tau start to entangle it. Prions is just everything just starts getting like the hoarders. It's like they're kind of taking everything inside of it. Now they're working with some antibodies. The antibody will
Stop
be
it from
specific
being
for
able
the
to
prion.
connect with another one.
Yeah, well, it won't stop it, but it'll sort of inactivate it.
Okay.
And it'll be, the antibody will mean that this one is not the functional protein. They're working on that. The problem is those things don't work well in the brain a lot.
Yeah.
I'll go back to prions later. We can talk about it a little later if you want to talk to them. All right, germicides. Go through these quick. Relative susceptibility of microorganisms. You have classification. A high-level germicide is going to kill everything. Peroxides will do this. Okay? Ethylene oxides will do this. We'll talk about those at the end, but these kill everything, including endospores.
So anything with oxide in it?
Ethylene oxide, we'll talk about them later. Just know what a high-level one is right now. It kills everything.
No, I'm saying like, is it fair to say anything with oxide and the, or no?
Which one?
Oxide, any oxide, is that?
Oh, it's going to depend on the level of it. Like hydrogen peroxide?
Yeah.
It depends on the level.
Okay.
You have pure hydrogen peroxide, that would fall into that level.
Okay.
Pure hydrogen peroxide will burn a hole in the table.
Wow, I didn't know
With a massive, oxide medium. Intermediate levels kill fungal spores, protozoans, cysts, viruses, most pathogenic bacteria. This is the one you look at most of the time. Low level are going to kill just vegetative bacteria, fungi, some protozoans, and some viruses. Okay? So give me some examples real quick. I gave you the top two. That's going to be ethylene oxide. It's going to be some of the peroxides. It's going to be some of the high level ones. What would an intermediate one be?
that. Would it be
You'd be surprised.
tough, like the ones they sell over the counter for like athlete's foot? I can't remember the
Those are
name.
antibiotics, antifungal drugs.
Okay.
We're talking about chemical agents or physical agents in this one.
That'd be like hand sanitizer?
Which one? Well, yeah, but what's hand sanitizer? Okay, let's go with that. Where do you think bleach would fall here? Pure bleach.
High level?
High level? You don't think high level?
Can it kill the endospores though?
Maybe intermediate.
Not gonna be intermediate, might get up close to high level, but you have trouble killing some spores in the people. It'll do it after a while, but. How about alcohol then?
Intermediate.
Alcohol is definitely intermediate. Most of them are intermediate. How about low level?
And so,
That's to be germers. I wouldn't throw because it's not germicidal.
Is that the
These
ones
are actually killing stuff.
you buy for your yard and your plants and stuff? Low level germicide? Or no?
No, those would be, I assume you're talking about actually exactly what I am. This would be things like ammonia.
Ammonia. I thought that was strong.
No, ammonia's not super strong one.
What about Cavicide?
Which one?
Cavicide?
Cat, that's gonna go away, that's gonna be an intermediate up here, because that's the whole point.
So even though that's what we mainly use like in the clinics and
Right.
hospitals, that's not even a,
Yeah,
wow.
it may have some phenolic compounds and prostate, it may, some of them, the intermediate one's really big, you almost have different levels from there. I have to look at Cavicide and see if it actually, it's a pretty potent germicide, I just don't know if it kills spores. That's one of my.
What does kill spores?
Huh?
What does kill spores?
Eating like those peroxides, high level peroxides, some of the real strong phenolic compounds, some of the ethylene oxide gases, radiation will knock them out.
Cause I know like the hospitals now, they have like certain wipes where like, they say like you have to wear gloves or else like you can get like some sort of like cancer from it, cause they're super like high in like alcohol.
I don't, I have to see, I have to look into that. You guys get those names for, I'll look up Cavicide and.
Yeah, cause I've seen them like at Trans Mountain, like they have them, like they have like two different ones, like there's one.
It's a red top, right?
Yeah, it's like a red top and you have to wear gloves when using them, cause like they can.
No, just because they're, okay, we'll come back to that later, we'll talk about it in a minute again. But is it just because it's an irritant, or is it actually potentially carcinogenic or toxic, or?
I don't know, they say it's pretty toxic, it's just something like can cause like some sort of like
Might be a
cancer.
phenolic compound.
I don't know what they have in it.
I'll have to look at that, I'll look into that, you guys get the name for it. Is it Trans Mountain Campus, where they have it, or Trans Mountain?
No, like the Trans Mountain Hospital, like.
Oh, okay.
it's getting there.
I'll look, see if you can find that. We'll look at that. How about biosafety levels? BSL-1,
Safe.
where would you find a BSL-1 lab?
Here?
Handling pathogens do not cause disease in healthy individuals, even some of the unhealthy individuals.
Here?
Is this a BSL level 1 lab? The one that we work in? You should know
That's
that.
like a high school lab, wouldn't it be like?
Yeah, it's gonna be, I could say my kitchen counter with BSL-1 lab, right? I have no people. But technically, I can get away with it. I mean, people do bench top work in their garage all the time. BSL-2s handling moderately hazardous agents. They can cause disease, sometimes in healthy individuals or in healthy individuals, but there are treatments or vaccines, or it's hard for them hard for you to catch them. Okay, things like that. They're not very virulent. Okay. Some BSL labs you use biosafety cabinets in. We'll talk about biosafety cabinets in a minute. I usually use. It's going to depend on how infectious it is, how dangerous it is, and how easily it's spread. Okay. Biosafety 3 labs handling microbes in biosafety cabinets. But aside from a biosafety cabinet, what else do you have to have in a BSL-3 lab?
Biohazard?
Has to have its own individual room. There a BSL-3 tech?
yeah, but I don't know.
You don't know it? BSL-3 lab, where is it down? Basement usually, right?
I think so.
So BSL-3 has its own room. It has a biosafety cabinet in it. gonna have don't autoclave, or it should. It's gonna have a door here. Okay? And it's gonna have negative pressure inside of the room. What does negative pressure mean? Why would you have it in the room?
You don't want air flowing out.
Right, if anything happens and that door opens, the air's gonna go which direction? It's gonna come in, good. They have an autoclave here, so anything that you use has to be sterilized before it leaves the room.
Mm.
These are moderately dangerous, not moderate, these are relatively dangerous pathogens, usually relatively or highly infectious. There are, however, treatments or vaccines for them. BSL-4 not only has this, but it's got its own room, it's got its own building for these things. Okay? The BSL-4 lab also will have 2 different chambers you have to go through. You come in here, you take off your clothes, and you put on a biosafety suit. Okay? And you go through this one. This is the shower room. Then you go in here, and I'll show you a picture of that. Then you're going to clip in to an air supply. And those are going to have positive pressure inside of it. Why would you want positive pressure in your suit, your biosafety suit? The rooms still have negative pressure, right? So if anything were to breach this door,
So then it will come out of the suit?
air's going to flow in. You want positive pressure in your suit because if you get a tear or rip in it, the air should push anything out, hopefully. Good. These also usually have, I don't know if they do anymore, the old ones used to have self-destruct mechanisms
Wow.
where they would
Where
flood
would
the
one
area.
of those be?
Huh?
Where would one of
But
these?
that's why I don't know if they have those anymore.
No.
There used to be 3 in the US.
CDC's?
CDC, USAMRIID, and then Galveston, UTMB and Galveston had one. I think Chicago had one, and UCLA has one. Now they're popping up all over the place. Kind of freaks me out a little bit. There's one outside of San Antonio now.
Wow.
What do you study in these?
One of the most dangerous.
The most dangerous exotic pathogens out there. No treatments, no vaccines,
Oh, jeez.
high mortality rate, high infectious rate, Ebola,
Zombie apocalypse.
Marburg, huh?
Zombie
Zombie
apocalypse.
apocalypse virus. Hantavirus is in there, but now they have treatments for Hanta, so they don't do it as much anymore. Anything new that comes creepy crawly out of the rainforest, they're going to build them. Okay. When you leave this, you have to stand in a shower here, and you actually get disinfected in that suit.
And how much do those guys get paid?
Not as much as they probably should. So here's the guy working inside of here, and it says, like I said, it says positive pressure inside of here. So if he gets it there, then hopefully it'll push everything out. And again, before he leaves the room, these all have locks on them. You cannot open this door, A, until this one's closed, and B, until you've actually taken a shower and disinfected these. I'm going to have biosafety kind in there. I'll show it later on. All right, give me some examples for BSL-1. Hmm?
Kitchen.
Or bathroom?
No, organism.
Oh, organism.
I was in bathroom, I called BSL-2 that before, maybe even a 3.
And stop it.
Staff, which one?
The one that's.
Staff epidermis? Yeah, that's gonna be BSL-1 for sure. How about E. coli?
Oh, yeah.
Yeah.
Coli would be BSL-1. You probably, well, 0157 might pop up too. I would still think it's a 1. Lactobacillus. Some of the soil bacteria that are not pathogenic. Anything that's not really gonna cause problems. That would be BSL-2.
This,
Art.
Listeria, what is it?
Listeria probably be BSL-2. MRSA probably be BSL-2 still.
Really?
Inside, I'd probably be doing it in the hood, but it would probably be a BSL-2. You can still treat MRSA. It's not super infectious, huh? Salmonella, E. coli 157. Anything that's going to make a healthy person sick would pop up into a BSL-2 lab. So what do you think ours is in the lab?
2?
Ours are 2. We can do 2 on there. We can't do stuff like viruses or things that will aerosolize, so we don't have a biosafety cabinet, but we can still work with some of the moderate BSL-2 organisms. How about a 3?
Tuberculosis.
TB is a big one. A lot of people think TB is a 2, TB is a 3. Why is it a 3?
Highly infectious?
It's actually not that infectious. It's kind of hard to catch TB.
It's hard to treat, it takes like months of treatment.
Hard to treat, takes like a bunch of treatment. It does aerosolize, although it is hard to catch, but it could get out. There's a lot of resistant strains now, and it's hard to kill.
Hard to-
How about 4? We talked about 4. How about the flu?
What? 4? Really?
No.
Oh.
How about the flu?
Oh, that would be like a 2?
Two, I don't know, if you think a lot of 3s, do a lot of influenza, they still do a 3.
Oh.
Everybody does it in the 2. Problem is, it's very easy to catch. I need to check, I don't think it would be a 2, but he's not that even out. Somebody's wrong. How about HIV?
Oh, that's probably like a 2.
A 2?
Yeah, because it's hard to catch.
That's a 3.
I say
It's actually 2.
Okay, yay!
Since I've had it done there, so it was a 3 for a while. They moved it down. There's some people who they can actually do it in a 2 now. So it's kind of weird the way they set it up.
So what's a 4?
4 be Ebola.
Ebola.
Things like that. Hanta virus, or Hanta down.
What is
Marburg
Hanta?
virus, any of the one of the hemorrhagic fevers out there, things like that. All right. So key-related methods. You all know this works. Denatured proteins, we'll go over this again and again. Interfere the integrity of cytoplasmic membrane, disrupts structure and function of nucleic acids. If you heat up nucleic acid too high, what do? When you cook your food, how are you killing the bacteria in the food you cook? Denatured the proteins, disrupt the cytoplasmic membrane, disrupt the nucleic acids. Thermal death point is the lowest temperature that kills all the cells in a broth in 10 minutes. And the thermal death time is the time to sterilize volume of liquid at a set temperature. And we go back and look at all these when we talk about autoclaving and we look at boiling and stuff. Okay? Just know the definitions of these two, because things can change this. Moist heat. Use to disinfect, sanitize, sterilize, and pasteurize. Again, this is going to be redundant. It's going to denature proteins, destroy the cytoplasmic membrane. It's more effective than dry heat. Why? That's what I want to feel. Why would moist heat be more effective than dry heat?
Isn't it also kind of like diluted? Sort of?
Not diluted.
Is it because it can catch more? Like it can contain more, maybe?
Not much containment. I think you guys are thinking about it. If you stand, if I stand outside at 70 degrees in the air, can I stand out there all day long and be fine?
Oh, is it because of osmotic pressure again? Or?
Not osmotic pressure, but can I just stand outside at 70 degrees and be fine?
Yes.
No? Yeah, I can tell you.
Yes.
You just get hotter.
Huh?
Like when it's moist, you just get hotter. Like water, like conducts you.
It conducts you, that's what I'm going for. Could you stand in a pool of 70-degree water all day long?
No.
Why not? Water conducts heat better, so that cold, that heat's going to want to move out into that water and conduct it away. You're not going to do much in air. So moist heat conducts the water better. Okay? I'm not the water, the heat better. So let's go through these different ones. I'll let you guys go, so I ain't even talking today. Moist heat is going to be boiling. Kills vegetative cells of bacteria, fungi, protozoans, that are trophozoites in most viruses, most pathogenic viruses. The difference is boiling time is critical. You might can explain to me why. If you've ever looked on a package of stuff you cook, a lot of it has high altitude instructions. Have you ever noticed that?
Mm-hmm.
We're actually above that level here. I think it's 4,000 feet, isn't it, for a lot of them? Why? Different elevations require different boiling times. Why?
Because it boils slower and so it'll take longer to kill. And
Boils lower, boils lower.
it boils slow. It takes longer to boil in certain elevations, so it'll take longer to kill the pathogen.
Does it take longer to boil?
Pressure and temperature are related.
Right.
So, I don't remember, but the higher the pressure, I think, like, it drops or lowers the
The
boil-
heat?
I don't know.
Yeah, people get asked, we're biologists. Let the chemistry deal with that. You know it? Or,
Yeah, low pressure boils faster.
Right, so the air pressure is pushing down. When you're boiling something, the point is you want to get to a temperature. Boiling is where it goes from a liquid to a gas stage, right?
Right.
The higher the temperature, the higher the pressure, the higher the temperature it takes to get water to go from liquid to gas. So something that boils at sea level, at 100 degrees centigrade, is going to boil at 6,000 feet, it may be 95 or 96 degrees centigrade, which means the temperature is less. It's still boiling, but it's at a lower temperature. So the higher you are, the longer you have to boil things because the temperature is less.
Because the
water
temperature.
vacuum boils.
Oh, like that?
Yes.
Yeah, because that, and that's what lyophilization is. When you pull a vacuum out of something, you want to lyophilize something, what you're doing is you're increasing that pressure and it just comes up. Good. So anybody go camping here? Anybody campers here? 3, 4, 5. That's why you make sure whenever you go camping, they tell you what? At altitude to what? So we have some sick campers here. Make sure you
Boil your water
stuff
first.
longer because it boils at lower temperature. Autoclaving is pressure supplied to boiling water prevents steam from escaping. So the hottest you can get water that is not pressurized is 100 degrees centigrade, right? Steam is 100 degrees centigrade in the open air. If you put it under pressure, it can get hotter than that. And the hotter it gets, the more pressure it makes. So it's kind of this vicious circle. So boiling temperature increases as pressure increases. You increase the pressure, you can get the steam hotter and hotter and hotter because that's the same thing we're talking about. Harder to get it go from a liquid phase to a gas phase.
So is that kind of like with the pressure cookers?
It's exactly what a pressure cooker is actually. Autoclave is just a fancy, expensive pressure cooker, what it is. 120, and you can set it more precisely. 121 degrees centigrade for 15 minutes PSI. 15 minutes at 15 PSI kills everything except prions. The whole point of this is to kill what? Why do you have to go through all this trouble? What are you trying to kill with an autoclave that you can't kill just by boiling or heating up?
Hyper.
Endospores. This is the one thing that you're trying to have to do to get rid of endospores. This temperature, this pressure, forces that hot water into the endospore and actually kills it. Here's what it looks like. Looks like. Everybody, all dentist office should have this. All tattoo parlors should have this. Although most things tattoo parlors are now what? Anybody got any ink right anyway? Nobody? They're all pretty much disposable now. They should be. I think most of them are disposable. 5 dentist stuff in. All right, so I'll end with this little fun fact. Fun little fact.
Uh-oh.
There was a dentist in Tulsa whose autoclave broke.
Oh, I remember you saying.
He decided that he didn't need to fix it. Anybody heard this before?
Yeah.
You did?
You said it before.
I did?
Yeah.
Yeah.
He gave.
Oh, I forget that. I've got a meeting with the dean today during lab.
Oh, the colonoscopy too. He told
Yeah,
us
that's
that.
what I went over today. So, it's supposed to start right at 11 at lab. It's only supposed to be 30 minutes to 45 minutes, but you know how those things go, right? It could go longer. So what I thought I was going to do for you all is, a lecture in my class. I don't want you guys to have to stick around for, I don't know when I'll be back. I want you to go research a parasite. Then maybe in the semester, if we need some extra credit, you have to give a presentation on a particular parasite, right? Parasite. Not an ectoparasite, so not a flea or tick, it's gotta be an endoparasite. Okay?
Endo.
So I'm gonna let you use this day as a day to research that. So next, for Wednesday, I want you to bring me 3 parasites. that you're
Into
interested
lab,
in.
like actual physical ones, or just the research?
Just the research.
Okay.
Just the name. So we don't have any overlap, and we can start going through that, right?
A parasite, do you mean like a bacteria or like an actual?
No, more like a no bacteria, you're right. So like no viruses, no intracellular bacterial parasites. Something that would fall into that general category. So a worm, a protozoan, a fluke, what else we got in there? Any of those types.
Okay.
Anything like fungus? Yeah, you can do fungus. You
Like
want to
a,
do it?
like, athlete's foot, that's kind of a parasite.
Which one?
Athlete's foot, no. Well, that's ecto, right?
Yeah, that would be grammatified in it. Yeah, just I mean, please take a little more. Do something. I tell you, the reason I like the protozoans is because they have more complicated life cycles. That's why it's so they're just interesting. All right, guys, go down and we'll figure out. I'll think about it. Maybe. We only covered 1 chapter since last time.